Okay, simple harmonic motion. Simple harmonic motion is sometimes written as SHM, simple harmonic motion. Is the simplest of all in periodic motion. The type of periodic motion that is the simplest of all is simple harmonic motion. For example, examples of simple harmonic motion are simple pendulum, and spring mass system, just like this. The body is said to be under simple harmonic motion if it is periodic. If the type of motion is periodic, it is said to be simple harmonic motion. Periodic means that if the motion repeated itself at a regular interval of time, the type of motion is said to be periodic. This means consider this as simple pendulum. It oscillates here and there. It repeated itself at a regular interval of time. Because of this is periodic motion, because it repeated itself at a regular interval of time. Because of this, simple pendulum is simple harmonic motion, or it can be periodic motion. In similar way, a spring mass system oscillates up and down. It repeated itself at a regular interval of time, moving up, down. Because of this, it is said to be periodic motion. It repeated itself at a regular interval of time. Since it is periodic, it is a simple harmonic motion. Therefore, to be simple harmonic motion, it must be periodic. Motion. The other characteristics of simple harmonic motion is the direction of acceleration is directly proportional to displacement. This bob of the pendulum oscillates here and there. It has its own acceleration and displacement. Displacement at the equilibrium position is 0. This is equilibrium position. For a spring mass system, this is equilibrium position. They say this is 0. Now, this is maximum displacement A. The maximum displacement reached by this oscillation is said to be amplitude, here minus A. Here, let's say this is minus A. When the spring compressed up, it may be here A. Now, the acceleration of the pendulum varies from point to point. For example, if this is, let's say this is point 1, this let's say point 1, here point 2, this is point A. At point A, the acceleration of the bob of the pendulum at the equilibrium position, it will be 0. At 2, they have some value. At A, at amplitude, it gains maximum acceleration. Now, acceleration is directly proportional to displacement. But acceleration is directly proportional to minus x. Acceleration is directly proportional to x, but acceleration and displacement are in the opposite direction. Acceleration and the displacement are in the opposite direction. The direction of acceleration and the displacement are opposite, but they are directly proportional. Look, this spring mass system, in this spring mass system, when the spring is moving down, there is a restoring force of the spring that opposes the motion of the spring. When the spring moves down, the restoring force acts up. When the spring moves up, the restoring force acts down. Restoring force always opposite in the opposite direction to displacement. Therefore, from Hooke's law, restoring force is directly proportional to minus x. From this we have restoring force is equal to minus k times x, where k is the spring constant and x is extension or displacement. From Newton's second law, force is equals to mass times acceleration. This is the mass of the spring and acceleration of the mass of the spring. Now, when you combine these two equations, force, mass times acceleration, and the restoring force minus kx, the two forces are opposite in direction, but they are equal in magnitude, action and reaction force. This force and the restoring force are equal, but they are opposite. Therefore, when you combine these two, mass times acceleration is equals to minus k times x. From this, we have acceleration, divide both sides by mass. Acceleration is equals to minus k times x over mass. Look this equation. Acceleration is directly proportional to displacement. At the maximum position, acceleration gain maximum value, but they are opposite in direction. Acceleration in spring mass system, acceleration is equals to minus k spring constant times extension of the spring, displacement, that means, over mass attached to the spring, the mass attached to the spring. Since this motion repeats itself at a regular interval of time, the motion of simple harmonic motion is expressed in sine function or cosine function. It is sinusoidal. It repeats itself at a regular interval of time, up and down. So graphically, the motion of simple harmonic motion, or simply the motion of periodic motion, is graphically represented or shown by sine function or cosine function. So the graph is sinusoidal. If this is x, here it moves up, down, up, because it moves up, maximum displacement, A, here minus A. Okay, sorry, this is time. This is time. This is time. This is x, time. Now, the time used for one cycle, this is one cycle. The time used for one cycle is said to be period. Time used for one cycle. Now, moving up, maximum displacement, and the return is back down and negative amplitude, and the return is back, one cycle is completed. Therefore, the motion of simple harmonic motion is graphically represented according to this. It is sinusoidal. It is expressed by using sine function or cosine function. X is equals to A times sine omega t, where omega is equals to 2 pi over period. For one cycle, angle is 2 pi, and the time used for one cycle is period. Therefore, angular displacement, angular velocity is equals to angular frequency or angular velocity. Angular frequency is equals to 2 pi over period, but this is equal to 2 pi times frequency. 1 over period is equals to frequency. So it is possible to substitute 2 pi over frequency instead of omega. Therefore, x is equals to A times sine of 2 pi f times time. This is expression for this graph. When the value of time is 0, x is 0. It starts from the origin for sine function, and it starts from maximum displacement for cosine function. But in simple harmonic motion, it is possible to express by sine function or cosine function. It is possible. Okay, x is equals to amplitude sine of 2 pi f times time. F times time, one cycle is completed. The time used for one cycle is said to be period. Generally, simple harmonic motion is the simplest type of periodic motion. Periodic motion is the type of motion that repeats itself at a regular interval of time. The body is said to be in simple harmonic motion if its acceleration is directly proportional to displacement, but the two, acceleration and the displacement, act in the opposite direction. Their direction is different. And if they are directly proportional, it is simple harmonic motion. It must be periodic type of motion. It is periodic. Here, acceleration at the equilibrium is equal to 0. Acceleration, the value of acceleration, since it is directly proportional to displacement, x is 0 as the equilibrium position. This implies as acceleration is 0, but acceleration is maximum at amplitude. At amplitude, acceleration is maximum because acceleration is directly proportional to displacement.